In this video, we are going to look at activity 7C, which is the particulate modeling of limiting reactants activity. And the goal of this activity is to help you better understand what it means for something to be a limiting reactant. So let's start with looking at the instructions. It says, for each word equation, write a balanced chemical equation, draw a particulate representation of the reaction, making sure that you include the correct number of each particle based on the information provided, and then determine which reactant is limiting and which is in excess. So let's first look at number 1. It says 3 molecules of oxygen react with 4 molecules of hydrogen to produce water molecules. And the first part that we need to do is write the balanced chemical equation. So when we're doing this, we can't pay any attention to how many molecules it says in the problem. We just need to write the reactants and the products and then balance the equation with coefficients. If we write 3O2 plus 4H2 yield H2O, that's not going to be a balanced chemical equation. We need to start by just predicting our reactants and products. We have oxygen. Oxygen we know is diatomic, so it's going to be O2. Reacting with hydrogen. Hydrogen is also diatomic, so it's going to be H2 to produce water. So producing H2O. So now we have our equation and we need to balance the equation. So I notice that oxygen's out of balance, so I'm going to put a 2 over here to balance out oxygen. And when I put that 2 there, I knocked hydrogen out of balance, so I'm going to put a 2 over here to balance out the hydrogen. And then it looks balanced, so I'm going to fill in a 1 in front of O2. And I'm also going to fix my arrow so it's a little darker there. 1 O2 plus 2 H2 yields 2 H2O. So before the reaction happens, this says that we have 3 molecules of oxygen. So we have 3 O2 molecules. So my oxygens are supposed to be circled. An O2 is going to have 2 oxygens together, so I'm going to make oxygen molecules. I'm going to put 3 of those in my container. And then it says we have 4 molecules of hydrogen, and each hydrogen's a square, so I'm going to put 2 squares bonded together in molecules. 1, 2, 3, 4. Okay. Now we need to figure out how much product can be produced with these reactants. So we need to make an H2O molecule. So 2 hydrogens and an oxygen. So I'm going to put 2 squares and a circle together. And then every time I use one of them as a product, I'm going to put a check mark by it in my reaction beaker. So I used one of those, and I used 2 of my squares. Okay, so I can make another one. So I'm going to use 1 circle and 2 squares. So I used 1 more circle and 2 more squares. So I still have enough to make more. 1 more circle and 2 more squares. 1 circle and 2 squares. Then I still have enough. 1 circle and 2 squares. Okay, so 1 circle and 2 squares. And now, look, I'm out of squares, so I don't have enough to make any more water. I only have leftover oxygen. So now I'm going to draw that leftover oxygen in my beaker for after the reaction has occurred. So now, once I have this picture, I can look at it to determine what reactant is limiting and which one is available in excess. And to me, it's actually easier to first think about which reactant is available in excess. So excess means that it's left over. You have leftover reactant. And so here I can see clearly that I have leftover oxygen. So my oxygen, O2, is available in excess, which means that my other reactant, my hydrogen, is my limiting reactant, H2. And remember that a limiting reactant is the one that runs out first and stops the reaction from happening. So because we ran out of hydrogen, we couldn't produce any more water molecules, so we just have leftover oxygen. We have leftover reactant once our reaction is done happening. So there's our first one here. So next let's look at this one. 2 sodium atoms react with 3 water molecules to produce sodium hydroxide and hydrogen gas. So first we need to write our balanced chemical equation. So we have sodium atoms, just sodium by itself, Na, reacting with water molecules. So water is H2O, but I'm going to write it HOH because I know I'm going to have hydroxide later on. So HOH, and it's producing 2 products, sodium hydroxide, so I'm going to do my crisscross, sodium plus 1 and hydroxide OH minus 1, so NaOH, and hydrogen gas, which I know hydrogen's diatomic, so it's going to be H2. So now I need to balance my chemical equation. So I notice that I have 3 total hydrogens over here. I have an OH, and then I have 2 H's. So I'm going to balance the H's here with the H in my water. So I'm going to put a 2 in front of my water molecule. But when I did that, that threw off my OH count. So now I need to put a 2 over here, and then I need to put a 2 in front of sodium to balance my equation. And then I'll put 1 in front of H2. So I have 2 sodium plus 2 water yields 2 sodium hydroxide and 1 H2. So now we need to draw our particulate representation of the reaction. And it says we have 2 sodium atoms. So I'm going to draw 2 Na. Sodium is supposed to be a triangle. 2 sodium atoms that are individual by themselves, reacting with 3 water molecules. So 3 H2Os. So H2O. So I'm going to draw HOH. And I'm going to draw this 3 times. HOH, and then HOH. 3 water molecules to produce sodium hydroxide and hydrogen gas. So for this reaction, I'm actually going to look at this a little bit differently. So I am going to actually circle the things that I'm using to produce product and see how many times I can do that. So I need 2 sodium and 2 HOH to react together. So 2 sodium reacts with 2 HOH. So I can do my reaction once, but can I do it again? Well, it looks like I can't because I'm already out of sodium atoms. I have no more sodium to react with water. So this is going to end up being my excess reactant. Excess reactant that's left over once the reaction's done. So let's go ahead and draw what we get as our products. So we're going to get NaOH, 2 NaOHs, and 1 H2. So Na, sodium, is a triangle with an O and an H, with an O and an H. That's 1 molecule of NaOH, and then we're going to get another NaOH. So 2 NaOHs and 1 H2. H2 is just 2 boxes connected to each other. And this makes sense. So I used 1 triangle, 1 triangle, 1 triangle, 1 triangle, 1 O, 1 O, 1 O, 1 O, 1 box, 1 box, 1 box, 1 box, and then 2 boxes, 2 boxes. And then this is my excess reactant, the part that did not get used. So I have an excess water molecule left over at the end. So this makes it really easy to figure out our excess reactant. So that would be HOH, which is water. So I'm just going to write it as H2O. And then which reactant is limiting? Well, it's our other reactant. So we said HOH is our excess, so sodium must be our limiting reactant, Na. So there's several ways you can think about these problems and do whatever works best for you, but do draw yourself a picture to make sure that you are understanding what is occurring in the reaction. Next, we have 4 aluminum atoms are combined with 3 chlorine molecules to produce solid aluminum chloride. So we need to start by writing our equation. So we have aluminum atoms, so just aluminum by itself, are combined with chlorine molecules, so we know chlorine's diatomic, so it'll be Cl2, to produce aluminum chloride. So we need to do our crisscross. Al has a +3 charge, chlorine has a -1 charge. So we get AlCl3. It's crossing down. So now we need to balance our equation. We have an odd number of chlorines. I'm going to go ahead and put a 2 here to make that number of chlorines even. So now I have 6 chlorines, and I can do 2 times 3 to get me 6 on the other side. And then aluminum, I have 2 on the product side, so I need to put 2 on the reactant side. So now let's draw our picture. So it says 4 aluminum atoms. So 4 aluminum atoms, 1, 2, 3, 4. Are combined with 3 chlorine molecules. So chlorine, 1 molecule, 2 molecules, and 3 molecules to produce solid aluminum chloride. So now we just need to figure out how much can be produced from our reactants. So this time I'm going to I'm just going to circle what will be used first. Let's do it in a different color, in fact. We'll do it in blue. So I'm going to use 2 aluminums with 3 Cl2s. So 2 aluminums with 1, 2, 3 Cl2s. Okay, so I've done my reaction once, but I don't have any Cl2 left. It's all used up. So these aluminums are in excess. This is excess aluminum. So now we just need to draw what our products will look like. So if we make 2 AlCl3s, we can use aluminum with 3 chlorines. So an aluminum is used with 1, 2, 3 chlorines. 1, 2, 3 chlorines. Okay, we did that once, and then we use the other aluminum with the other 3 chlorines. 1, 2, 3 chlorines. 1, 2, 3 chlorines. Okay, and we've used up everything that we can, and we just have leftover aluminum. So we'll just draw our leftover aluminum atoms. These are excess reactant. They are not a product, they are just leftover aluminum. Excess aluminum. So our excess reactant is aluminum, and our limiting reactant is our Cl2. This problem says 2 sodium atoms are combined with 3 chlorine molecules to produce sodium chloride. So sodium in A is combined with chlorine molecules, so we know chlorine is diatomic, so Cl2, to produce sodium chloride. Sodium chloride, Na plus with Cl minus to give us NaCl. So we need to balance, so we're going to put a 2 in front of NaCl to balance out the chlorine, and that means we need a 2 in front of sodium as well. And then we can fill in our 1 in front of Cl2. We need to draw our particulate representation of the reaction, and this time it says to make our own key. So I'm a fan of colors, so I'm going to use different colors to represent our different molecules. So I'm going to say sodium is going to be green, and chlorine, each of them is going to be red. And I'm just going to use all circles this time. So we have Na and Cl, and we need to draw our reactants and products. So we're starting off with 2 sodium atoms. So we need 2 green circles, just 2 green circles by themselves. Okay. And then we are also starting off with 3 chlorine molecules, so 3 Cl2s. 1, 2, and 3. I'm going to color all those in. Okay, and we want to produce sodium chloride. So I'm going to circle what it is that's going to be used if I do the reaction once. So I'm going to use 2 sodium, so 1, 2, and I'm going to use 1 Cl2, 1. So I did my reaction once, and I'm already out of sodium, so chlorine is going to be my excess reactant. I have excess chlorine. Excess. So now, when I'm going to draw the picture of once the reaction occurs, I'm going to end up with 2 NaCl. So Na bonded to a Cl. So I used 1, 2, 3, 4, and I have 2 extra molecules of chlorine just floating around still. Excess reactant just left in the container. I'm going to color my picture in. And we'll color these green. So this is not a product. This is just excess chlorine. Excess reactant, which is Cl2. This is our excess reactant, and these right here, these are our product of our reaction. So, which reactant is limiting? Well, the limiting reactant is the one we used up, which is sodium. And then the one that is in excess is chlorine, Cl2. So our final problem here is a little different. It says, assuming the reaction goes to completion, draw the product particles in the box on the right. And it goes ahead and gives us the balanced chemical equation. It says x plus 2y yields xy2. And so it seems like this is balanced, but it's always a good idea to check to make sure an equation is balanced correctly, because it could be balanced incorrectly, or it could be partially balanced and not completed, and it could just be there in order to trick you. So always double check. So we have we have one x on the left side and one x on the right side, so that looks balanced. And we have two y's on the product side and two y's on the reactant side, so that also looks balanced. So this is balanced. I'm going to put a 1 here to remind myself that this is fully balanced. So we each have a picture here, so we need to figure out, and circle how many x's we'll use per y. So we're going to use 1x, so x is a square. We're going to use 1x with 2 y's. So 1x and 2 y's, that makes 1xy2. So xy2. So we made 1 of them, and then we're going to do it again. We're going to try and do it again. So we're going to use 1x and 2 y's to make another xy2. Okay, and if we can, we're going to do it again. So I see another x, and I see 2 more y's, so we're going to make another xy2. Okay, and then we're going to try and do it again. So let's see, do I see any more x's? Well, we've used all these. I don't see any more x's, so we can't actually make another molecule. So we're just left with excess of y. So I'm going to redraw that over here. These are my excess reactant that's just left over at the end. Excess reactant. Here and here. So my excess reactant is y, and my limiting reactant is x.